Good morning, mathematicians. We're back at it with another normal office hour. What else is there to say? See what's in the math news, see what's happening on archive, I guess. The usual.
See what's in the math news.
Hello, Owners Effects.
I guess.
Hope you're doing well. Let's pop this chat out of here. Liberate chat.
The usual. See what's in the math news. Hello, Owners Effects.
No spectral sequences? I mean, we could get into spectral sequences. I mean, today is not an official spectral sequence day. There's no law against talking about spectral sequences yet. Just you wait, though. Just you wait till I have power. Oh yeah. I love seeing fractal me here. How many layers deep? I guess it only goes, 3 layers deep? Tragic. How could I make it go yet another layer? Coffee always. Coffee always. Hello, Locke. How's it going? Let's pop by Reddit. Let's see. There was fruitful discussion there yesterday. A video of Grothendieck? What? See, here is a place where I should, here's a place where I should probably open this video using, Brave. So I don't have to watch ads. But I don't know what tab I had open last in Brave, and for whatever reason, Brave saves your tab and brings you there. Interesting. I don't think I've ever seen this. Grothendieck at the beach. Who's got the better delta function? Good morning, a Guitar Freak official. Oh, good morning. Yeah, okay, we're already in different things. I'm probably gonna keep. I'm gonna try to keep it short today. And I will have to run off in like 10 minutes to switch over my laundry. It sounds like every French person you've ever met. Weird. It's like they all speak the same language or something. Yeah. What are we looking at here? We could look at the triality paper. I feel like I don't have the mental capacity for this quite yet. But yeah. We can also wait till Arad shows up. I think he wanted to discuss this paper. I think I have a bookmark for what's this paper? I thought I had a bookmark. Je ne parle français. I thought I had a bookmark. Dang. I found Oh yeah. Oh, he's omnipresent. Okay. Well, let's jump into triality. I thought I had found a link to the real analysis game. Um, and then I lost it. I don't know where I put it. Omelette du fromage. Oui, oui, Boris. Okay. Let's just look at this then. Could maybe have a look at the principle of equivalence and lab page. Oh yes, you did bring that up yesterday. No, Arad is here. He's right above you in chat. Je ne parle pas en français. Well, I don't have to do anything. I'm gonna invent my own new French. I am moose coded, yeah. How could you forget, Boris? What do you want me to look at here, Locke? Sensible reasoning in mathematics in general, in particular the higher structures, should be suitably invariant under respective notion of equivalence. Sure. For instance, a category can be presented by a simplicial set, the nerve, but the isomorphism of simplicial sets is much finer than equivalence of their corresponding categories. It's generally a mistake to mix up these two levels, for instance, and assign a category properties that are shared only by some of the simplicial sets representing it. Okay. The idea here is to generalize in many directions, not only properties, but constructions involving categories functors. Okay. The gist is you don't want equations. See, for example, Dagger categories. That was in the table of contents. The idea that comparing by equality is bad. You've never thought of it like that before. Oh. Well, yeah. You should read then let me send you a reference. Gosh, I forgot who it was. Am I reading this correctly? No, wait, who was it? Chat, you know who I'm trying to, you know the article I'm trying to reference because I've told people in live streams a million times to go read this article. Chat, you gotta help me out. Intentionality, invariance, and univalence? Is this what it is? No. Damn it, who was it? Maybe this is the actual article? No, I don't want these slides. Damn it, where's the... Why can't I remember this name? That's bad. That's bad for me. Yeah, better be careful, Locke. You come in chat with questions, you're gonna leave with homework. But what is a category presented? What does a category presented by a simplicial set mean? Well, I assume that means it's Wait, what does it mean to be? That's actually a good question. What, that it's representable by some functor, can be presented. Yeah, sorry, I don't know. What does it mean to be presented by? Oh, it means this, that the nerve of the corresponding strict category. The nerve of a corresponding. See there? What? What is there? What? Oh, nerve. Nerve something something full faithful. Why? The nerve of a corresponding strict. Oh. Oh. A category is presented by a simplicial set if it is the nerve of a strict category? Oh, that's what it means. I don't know. I don't know, John Smith, if that makes any sense to you. But, yeah, nerve. That makes sense enough to me. Truly insightful. Yeah. Bird coded. Yeah. Damn, I wish. Why can't I remember this? What is it called? Maybe I've got it. Equality. Was it Lever? No. Quality. Isomorphism. Hello, Sergio Polar Bear. What's this? I'm upset. I can't remember the name of this article. I'm also upset with all of you, chat, that you don't remember what article I'm trying to find. Ambiguous in what sense? Set equality is also ambiguous? Yeah, in what sense is it ambiguous? That's the least ambiguous thing I've ever seen. Co-homology video is good. Glad to hear you enjoyed it. Damn, that's really bugging me. Okay, whatever. Let's look at this triality paper. Oh, I have to go change my laundry over right away. So how do I entertain you guys while I run downstairs? That's the question. Mind you, it looks like chat is popping off, so maybe you can, maybe you're capable of entertaining yourselves while I leave the room for 2 minutes mid-live stream. I believe in y'all. But I'm going to wait a second because despite the fact my timer is about to go off, I do find that the washing machine experiences time slower than the timer on my phone does. Elevator music, yeah. It's my jam. It's my true jam. Okay. Okay, have fun, kids. Don't get in any trouble while I'm away. Okay. I've returned. Did you guys get yourselves in trouble or what? Since everything's a set, and set theory is encoded in sets, then in theory you can ask for any two objects in math, whether they're equal. You never really agreed with this criticism, though? Yeah, me too. I don't think it's that crazy. Yeah. You think 2 equals this in the standard encoding? Yeah. Is he staying just very still so you can't see him? Yeah. I figured out, Leo, that you're enabled to see movement. You're like a T-Rex. Is that true or is that just a myth? There's no way that we knew that, right? I thought there was... Isn't there some myth or something about like, a T-Rex is T-Rexes can't see movement or something? Have a harder time seeing you. I mean, maybe there's logic there based on, I don't know, how large animals act. Who knows? Takes you a week to walk down to your laundry room. Yeah. What can I say? Just a talented guy. T-Rexes are definitely a myth. Velociraptor. And we do not know that, yeah. Jimmy Neutron said it was a myth. Well, then it is. You're about T-Rex sized. Okay. The camera doesn't make it seem that way. But of course that's the tricks of Hollywood. Actually, there was this interesting, I'm sitting in on the seminar right now on the orbit method. And what's really interesting is that it was mentioned in it that the outer automorphisms of a Lie algebra correspond to the Dinkin diagram. Which is really cool. So let's look that up. Yeah, maybe let's find this. Go here. Kind of interesting. Always wanted one of those fireman poles. Definitely get it when you're a rich postdoc. Yeah, do you think my landlords will let me install one in between here to get down to laundry more quickly? If I ask nicely. Everyone is probably homeomorphic to a T-Rex size version of themselves. Yeah. I made a short simply stating the weird thing about the automorphisms of S6, but actually, I never got my head around it myself either, Boris. But that's been something on my mind, is that maybe I should actually make the full video explaining it. There's like 3 different explanations. So, there is, of course, a complete classification, blah, blah, blah. Oh, it's in Fulton Harris? The group of outer automorphisms of a simple Lie algebra are precisely the graph automorphisms. Oh, it's in Fulton Harris. And in Humphreys. I've got hard copies of both those books. Nice. Very cool. Type B and C have no outer automorphisms. Interesting. And then this is the automorphism swapping the endpoints. Wow. Okay. Huh. That is very cool. You refuse to stop using the word just because Elon stole it. Grokking something should still mean that you're feeling it in your bones. Yeah. Fulton Harris, D40. Fulton Harris. I know I've got a hard copy or a digital copy somewhere here. I'm sure if I just Google it, it'll come up. Okay, whatever. We'll just go to Google and we'll just look it up. I'll just look at the digital copy on the internet. We'll just do it this way. So what other way are we gonna do it? What other way are we gonna do it? Yeah, you gotta love it when the coffee hits my bloodstream and I finally start feeling like my normal self. D40, did he say? Somewhere in D40? Harris told you he wrote that book because he felt like he didn't get representation theory. So it was a good way to study up. Yeah. Are these Dinkin diagrams for Lie algebras related to Coxeter-Dinkin diagrams for Coxeter groups? Yes, absolutely they are. Absolutely, they're literally the same thing. Dinkin diagrams are slightly different. Well, you still get Coxeter groups, you get more general Dinkin diagrams, right? You get the extended Dinkin diagrams, but the ordinary ones show up, as well, if I am not mistaken, and I strongly believe that I am not mistaken, because the Weil groups are Coxeter groups. So you should be recovering. Hey, wait, did the appendices not appear in this online version? What a crock. Let's just say different up to notation. Okay. So you can associate Lie algebras to polytopes? Yes. Or rather, yeah. Well, not to all polytopes. Rather, you can associate polytopes to Lie algebras is maybe the direction I would say. Yeah, that's kind of what I'm doing in some sense, Leo lectures. Like, I really, it's kind of embarrassing, the things I've been working on for the category of modules script. Just getting myself really confused on doing all the extremely gory, gritty details of the proof, that the category, if you have a category with byproducts, that it gives you that it defines a semi-additive category. And so, like, I just can't find a very clear and compelling exposition of this. There's a lot of people talk about it, but I just do not like anyone's exposition. And the thing is, the proof is it's interesting because, like, the way that it goes is that in order to prove commutativity, you actually, as far as I can tell, you first need to prove the existence of the identity, and then you use that together with the proof. I think you use that in the proof of distributivity. And then once you have those, then you can use that to get to get the proof of commutivity. It's crazy. Hopefully I'll be dropping that video sooner than later. Leo lectures always coming in with the most cutting edge questions. Yeah. Yeah, Edie, I do want to better understand that as well. Also, I really want to understand, I think there's speaking of the classifying singularities, I really want to get my head around, what is it? There's like this one where it's like you take C8, maybe it's in here. Maybe it's in here, but there's some way that you see the E8 lattice by like, you look at some group action and there's some singularity. Yes, here. You look at some group action, you resolve some singularity, and then somehow this lets you see E8 as like a fiber or something. Somehow you get a copy of the E8 lattice. And I wish I understood it more. And okay, let me go off. Let me expose the secret crackpot that lives inside my heart. I really feel somehow I want this to have something to do with the missing Moore graph problem. Yeah. What here's what I'll say about it. Here's my really crackpot ideas about it vaguely. So there's some way that the Peterson graph, there's some way, this is in the book Algebraic Graph Theory by Godsil and Royal. It has something to do with the root system of E8. There's some way to get the Peterson graph out of the root system of E8. By the way, you can view the Peterson graph as you embed the dodecahedron in the sphere, and then you look at the image onto the is it CP1? No, but you I guess it's RP2. And you look at its image under the antipodal map, and you get the Peterson graph. Also, so this is one of, there's more graphs of known regularities, 237, the open questions about 57. Peterson graph is this one. The Hoffman-Singleton graph, which is the graph for this one way to view it, you can actually construct it inside the Leach lattice, which, by the way, is built from 3 copies of the E8 lattice. And in here, basically, there's some sort of way that you can view a version of the Hoffman-Singleton graph as sitting in here, because this has, you look at the points and you construct, it's, I think, the Higman-Sims group. And then inside that, with index 2, is the Hoffman-Singleton group, being the automorphism group of the Hoffman-Singleton graph. So clearly there's something, I mean, to me, clearly there's something going on with the Moore graphs and these lattices. Also, by the way, there's some way to view the E8 group as acting on some 57-dimensional vector space, allegedly, which I also saw from a Baez article. So something with 57. Okay, and then, sorry, I see there's a bunch of questions in chat. I'll address this in a second. But then also, let me tell you more about my crazy harebrained ideas. Speaking of, if we look at this, if we look at the sphere, right? And so remember, we've got something going on with the Peterson graph and the sphere. Well, the sphere, we also have a tiling of the sphere. So speaking of, we take the dodecahedron, right? How do we get the Peterson graph? You embed the dodecahedron in the sphere, and you take this quotient. But then also, what is the symmetries of this? You get the 2, 3, 5 triangle group. Well, let's go back, look over here. What do we have? 2, 3, 5, right? So somehow the appearance, like this is basically what we're doing. We create some sort of surface here. We're creating some sort of surface from this 2, 3, 5 equation. And then blowing up some singularity and getting E8. I have no idea what to make of all of these. Like I said, this is real. I don't actually lose a lot of sleep over this, but this is my real crackpot side coming out. So let me highlight another connection. The 2, 3, 7 triangle group, by the way, corresponds to the Klein-Quartic curve. The Klein-Quartic curve, which, by the way, has the same automorphism group as the automorphism group of the Fano plane, being PSL27. In fact, that's not just a coincidence. If you draw the Klein-Quartic curve and you look at like certain intersection points, you can find a bunch of copies of Fano planes. There's another article of John Baez that explains exactly how to go between the Fano plane and the Klein-Quartic curve, and you can actually interpret certain features of the Fano plane as features of the Klein-Quartic curve and go back and forth. And by the way, one of the other ways to construct the Hoffman-Singleton graph is to build it out of a bunch of copies of the Fano plane. Okay, I could keep yapping about my esoterica about this, but actually I need to go. I've already been here longer than I said I would. I am a Baez fangirl. That's true. Yeah. Doesn't an abelian enriched category automatically give you byproducts? Yes, but I'm going the other way. I'm saying suppose that you have a category with byproducts, and then I'm saying that you can define a semi-additive structure on that category. And in fact, any abelian enriched category is, you can actually define that structure internally, and this is part of the proof that there's a unique way to be like abelian enriched. Yeah, the identity is pretty quick. Unique terminal initial object? I meant the identity morphism. The point is that just with the structure you get from the category, you get abelian enriched structure for free. Actually, that's not true. You don't get abelian enriched. It's only semi-additive. You don't get inverses for free. But if it is abelian enriched, you can still use this like internally defined thing to get unique. There'll be videos on this, hopefully soon. It's not special to E8 though. Works for any Dinkin diagrams. I still want to understand this better. When you resolve singularities, the singular locus gets bigger, and you can't escape this loop in your life. Your third semester, and sometimes, hello Sasha, by the way, and sometimes you struggle connecting the things that you learned in lecture to actual problems, like writing down any correct formal solution to it. Any tips? Good question. Good question. I'm not sure what tips I might have. I mean, presumably, maybe not. One would hope or believe that your professor would be giving some examples alongside those theorems. So, maybe one thing to do is go to office hours and ask them for some examples of direct applications. I mean, one would also assume, and maybe, I don't know, maybe they're failing to do this, but one would also assume that they're, specifically assigning homework problems, whether they're just for practice or for marks, directly related to that chapter. So another thing to do, presumably you have a textbook accompanying the course, and usually, hopefully, that textbook also has examples in it. And also the homework, the sort of hint is that, well, if the homework's in that section, then the hint is that somehow you should be applying the theorems from that section. So that's another thing to go do, is check out the homework from that section, and then, it's up to you to figure out how to apply the theorems from that section. Yeah. Yeah, so that would be my advice. You could also Google, applications of this theorem or something. You wonder what twists on twisty puzzles on nice polytopes become an operation on associated Lie algebras? I don't know. Hello, Abdullah. What is a Moore graph? A Moore graph is a graph that is k-regular with k squared plus 1 vertices, diameter 2, and girth 5. But I'm going to let you go look up what those words mean, because I need to get out of here and do some work. There should be a new IAS, but with cottages and a fake farm for fellows who hasn't anyone done this. Wait, what? I don't know what you're saying. YouTube channel Esoterica is your go-to sleep time channel. Good. Yes, you can email me. Anything, all the time, always. I can't always promise I'll answer, and if I do answer, I can't promise I'll answer in a speedy time. But sure, send me an email. My email's in the description of most of my videos. The identity morphism is part of the category structure. I meant the identity for the... Yeah, I meant the identity, because you define... So if you have a category with byproducts, you use and say you have two morphisms, alpha and beta, then you define the addition of those morphisms to be the... so this is the induced map from either the product or coproduct structure. This is the diagonal map, and this is the codiagonal map. And then you define it like this. And when I mean the identity is you want to prove that the zero morphism, say, is a two-sided identity. By the way, here's also something that I found interesting in my look into this. I don't know how to prove. So let's say you define this using the fact. So this should be it's a category with byproducts. So let's say you define this map using the coproduct nature of this object. I don't know how to prove that this is equal to the same map defined using the product nature of this without first defining this and then proving some things about it, which is crazy. But yeah. How many times in this channel do I review the 3n+1 problem? Not at all. Never. Shouts out to the information theory notes you were reading that just said you can find a triple of random variables whose mutual information is negative and gave no example. Night, Boris. Hell yeah. What a champ. A Moore graph is a graph that is more exactly. Still haven't learned spectral sequences. Well, thankfully you've got this channel, all the live streams. You can just teach yourself from those, right? Can you still join the Langlands party? Of course. Is it too late for you? I don't know. Probably not. You can always learn more. You can always learn more today than you knew yesterday. So why not? Come Join in, jump in. Water's warm, as they say. Yeah, maybe there is an Ekman Hilton. I don't know. The co-product stuff admits vast generalizations in homotopy theory under higher ambidexterity. Interesting. Okay, I've gone way beyond what I intended to today. I'm leaving for real now that I've caught up with chat. Thank you all for joining me, and I'll see you tomorrow probably. So, Q E D